As mobile penetration matures in most developed countries, growth and value generation are set to continue as more users come online in emerging markets. And new users such as the Internet of Things, IoT, augmented reality, the AR, and artificial intelligence, the AI, enter the mainstream. We can witness today how businesses have transformed to address the COVID-19 pandemic. COVID-19 is the first pandemic in human history where technology and social media are being used on a massive scale to keep people safe, productive, and connected while being physically apart. That's where 5G has been designed to meet the very large growth in data and connectivity of today's modern society. We will discuss further in our rapid fire panel session, moderated by Professor Dr. 𝗬𝗪𝗪𝗪. So before I introduce the first participant, allow me to say a few words on satellites. For years, satellites communication has remained standalone technology. Now with the next generation of satellites built from 5G architecture, they will integrate with networks to manage connectivity of cars, vessels, airplanes, and IoT devices in remote and rural areas. In the near future, 5G signals will beam down from space and support our terrestrial 5G infrastructure on Earth. The end result is a new space race for satellites. SpaceX, Elon Musk's private American aerospace company, last week launched an additional 60 Starlink satellites into orbit, bringing a total number of satellites in the Starlink constellation to 422. Without due delay, let me introduce Christopher Luanga from Singapore to discuss on the role of satellites in 5G.
Right, thank you. So I have a presentation with me. You guys are able to see it, right?
Yes.
Are you able to see my screen now?
Yes.
Okay, so hello everybody, it's nice being here. I'm Christopher and I do research in space physics at NTU in Singapore. And some of the things I also do is that our satellite lab also builds satellites. So I'm also involved in the building of satellites. But today I'd like to focus on just two aspects of bringing together satellites and 5G. And I would like to talk about the engineering aspect of bringing these two things together, as well as the business aspect, right? So I hope that through this short presentation, you see in what ways satellites can complement ground-based 5G networks to provide the services that people need, but also appreciate what are the difficulties perhaps for satellite-based, internet-based ventures. So satellites, of course, have been around for a long time, and for the longest time, we've seen them as connected with us through big antennas, right? So you have an antenna here that you are receiving your signals from a satellite that is what is called a geostationary, a stationary orbit, which generally is about 36,000 kilometers. So with that distance, one of the major problems has been that latency is an issue. The time it takes for a signal to go back and forth is usually unacceptable for the people that want to access internet. And so people have known for a long time that one solution for this is to have satellites closer to Earth, right? Now, satellite closer to Earth usually see less area. So if you have your satellite in what is called a low Earth orbit, you're closer to Earth, but the trade-off is that you have to have a lot more satellites to cover the same region of space. So some of the key enablers for this recently has been the fact that actually building spacecraft has become very cheap. In fact, you can have high school students build satellites, maybe not supplying internet, but they can actually put together a satellite. So this is because of advances in both computing and manufacturing and a few other things that right now it's really cheap, both to manufacture as well as to launch. So that has made it possible for people to think about large constellations. If you hear in the news, it's 3,000, 4,000, it's 20,000, like large constellations. And these are possible now because financially, it's possible to put together satellites and do it fast enough. So if we have a LEO satellite, LEO constellation, that is low Earth orbit, closer to Earth, we have less latency, then we can now start talking about providing internet. So in my thinking, I think the engineering aspect of bringing these satellites and 5G is not the hardest bit. My feeling has been that it's more a business problem. So these are some of the carriers that we currently have around the world, right? Quite a number of them, quite a number of ground-based carriers. By ground-based, I simply mean that the base stations are primarily on the ground. There's no signal to satellite and back. And then there are a few satellite providers. These are the representative on my right. But what you will notice, the most part, is that when somebody is not connected, right? If they're not connected to a ground-based carrier, they very unlikely will be able to afford a satellite phone line, right? So I come from a country called Malawi, and I know for sure that if an individual is not connected to a local network, it's very likely they'll be able to afford satellite internet. So this is I guess the key challenge is the fact that we're trying to reach out to people who, on the one hand, would want to use, who really need to use the service, like people have said, reaching out to remote areas and so on, but who are also unlikely to afford that service. So right now, there are people who are focused on global internet. These are visionary companies, right? Of course, they've been satellite internet companies for some time already. These are traditional, so to say, and they are not large constellations in the same sense that the new companies are trying to think about this problem. So on my right are some of the companies or organizations that are currently planning to have large constellations to provide internet to the unconnected. As I've showed there are more than 2.5 billion people say that are not connected. So it's a large group of people that are without a mobile phone, or the internet is not acceptable, not of acceptable quality. So if you see on my right, all these companies, in fact, none of them so far have actually had a service that is working, right? And yet the engineering of it is almost already sorted. So in particular, I'd like to point out AST, which is thinking about this in a somewhat a different way, whereby they're thinking of directly connecting to the antenna in your phone. That is the antenna you use right now for the 5G network, or 4G network that we're connected to, for the antenna you have right now, you don't have a separate antenna for your satellite internet, because most other companies, in fact, what they're thinking is you're going to have an antenna and then on the ground that is distributed, right? So that obviously is harder to implement in the sense that if somebody cannot afford an internet connection on the regular one, they're probably going to find it hard to have an internet connection, buying a separate antenna and so on. So I think that a really promising aspect of this is that if you can actually beam down 5G directly without requiring people to buy extra equipment, this would be something that makes it much more likely that people we're trying to reach out to are actually able to connect. So generally, I think for me, bringing these two things together, I think the greatest challenge is the business aspect of it. It's the fact that yes, we have the engineering, and bringing together these two systems is a question of making the systems interoperable and so on. But the way that perhaps this is going to be approached is going to be very challenging, and that's where we need to come together as separate communities. The 5G or traditional community that supplies internet or phone service, and the satellite industries would have to come together to think of a different way of reaching out to these communities that we are saying we want to connect. Because for the most part, right now, it's not so much an engineering, but it's more how do we make it workable, right? So when we think of satellites and 5G, I think satellites being up in the sky, so to say, you have a greater geographical reach. So it's like a base station that's able to cover a larger area. That could translate to reduced costs of setting up because you have less things to have to set up, right? But also it could mean that you actually you need less base stations, so to say, right? Another advantage, of course, is that satellites don't just they are somewhat away from the Earth. So if there's a disaster on Earth, for example, we would still rely on a satellite connection, and that could be very helpful in times where we need to connect to a community that's run into a disaster and so on. So I do feel that there are many ways in which these two things can come together. And right now, as we are in this particular crisis, of course, it would be good to have access to places that are remote, and satellites would definitely play a role in that. And so I think that the challenges ahead would probably be, how do we come together as communities to make sure that we're able to create, so to say, working relationships, both in terms of engineering, whether in terms of protocols, in terms of how we do this from an engineering perspective. But more importantly, how do we come together to create business models that actually are sustainable in the long run? Because I do feel that it would, I mean, you cannot so to say build a business out of just saying we want to help the poor who are unconnected, but how do we come together to create a business or a sort of venture that is creating value for the owners, and so it's sustainable in the long run. So these are my thoughts on how satellites and 5G can come together, and I think it's an exciting field. It's an exciting thing. I'm involved in satellites, so that's primarily where I would say I have an understanding of what it takes to build a spacecraft. That's where I'm speaking from. But I would definitely love to hear thoughts on the other side, the 5G side, because that's a community that I see from a distance. So I wouldn't say too much about what it is that's involved there, but I do feel from my engineering, satellite engineering perspective, that it's definitely worth us coming together and offering these bundled services together. Thank you.
Dr. 𝗬𝗪cie from Reims, France, please go ahead.
Okay, thank you. So thanks, Kanayas, for organizing this wonderful session. Nice to meet you all the participants here. So today I am going to talk about some of my work on 5G core. So I am doing some open source development on the 5G core. So I am going to share you what I am doing and how you all can get benefit or you can contribute. So who I am, I have some background on telecom and IT technology background. So I work mostly in the SDN, NFV, 3GPP and containers and fast packet processing. So it's a kind of things, because of virtualization, we want to do a lot of network function in the x86 hardware. So this is my background. So these days I am a consultant on 5G networks. So I am working on some project on 5G deployment with different options, typically the option 5, and we want to see that we can integrate this 5G option 5. So it's you don't need to worry. So we are going to deploy 5G to integrate with edge computing, and then 𝗀𝗪ance is another 𝗀𝗪ance is another framework that we are using in the mobile core network to the life cycle management and real-time control on this whole network end to end. So in this talk, mostly I am focusing on my development on SMF and UPF. So this is my goal. So you may know that we are coming from the different generation of networks. So we are switching from 4G to 5G. So 5G is a kind of Swiss knife. So we could say it's used for many different purposes. So that's what the promise it's giving us. So we say it's a many vertical services. For example, massive internet connections, massive broadband connections, massive IoT connection, then ultra raw reliability, low latency and reliability. So this is a vertical service we initially thought. I think one of the new vertical service, I think the follower will going to speak about IPTV. So this is not yet standardized. So another promise from 5G is that many people talking about the private networks. So today in European countries, it's possible that you can get a license to operate your private network. So it's another option is that 5G have a lot of integration in terms of access technology. So 5G is not only for 3GPP access technology, it can be integrated with some non-3GPP access technology, for example, Wi-Fi 6 or Wi-Fi. And so this is 5G, so it's wonderful. But the problem is that how I can build a network in my own. So if I want to build a network, is that possible? No, it's not possible, because you need a lot of expertise, at least to understand 3GPP spec. You have some time and money to invest in. So normally it's coming from big vendors or some big organization can do. So this is the challenge that we have in front of us. Second one is, if you want to drive some innovation around the 5G network, not always direct. So sometimes it's possible. So it's, for example, if you develop your own papers and you contribute to the standard, then it's becoming a standard innovations. Otherwise, it's not that easy to try the innovation. So we have to take the control. So that's what I started to build one protocol. It's normally we use it between the SMF and UPF. It's we call PFCP. So I wrote it in Go. So initially, then I thought, okay, I have to integrate with some SMF and UPF module. So how to do, what to do. So this is what my journey started to explore more in this 5G core network. So what I do is here just show you some 5G architecture. So I am sure that I will not threaten you with a lot of acronym and a lot of call flow. So I try to keep as much as high level. So here that you know that your device want to connect to the data network. So data network is a DN. So you are making a session to the 5G core network. So that is, you will see that AMF, SMF. So there are so many acronyms. So my work is mostly involved in the SMF and UPF, as I said before. So initially I developed this PFCP protocols, N4 protocol. Then I look around that what we can do on SMF and what we can do on UPF. So to do this job, so you need to know what is SMF and you need to know what is UPF. So only way is to go through the 3GPP document. So we will go through the 3GPP document and see what is the role for the SMF in 5G core. So they list a lot of different things SMF has to do. So we are taking very strict basic features. As names say that SMF is for session management function. So this is the one to do your management of your session. So for example, user want to connect to the internet, he want to send a data. It means that he has to create a one session, then only he can able to send and receive a data. So user management is session management is one of the job SMF has to do. Then assigning the IP address for the use element is one of the option. So today that we are trying to support, I am trying to support through the static configuration. Then selection of UP user plane function is also the job. Then there are so many things. So we are not going through all the details. So this is what is we showed in the bold line. Started implemented on the Go program. Okay, so this is mainly is a simple Go library or on x86 hardware. We don't do any specific things on it. It's like a simple application on Go program. Then we will go for the UPF. UPF is a user plane function. So this is a very hardware centric. Before it's like a big box coming from the big vendors. They build a ASCII and things. So we here what I am seeing is a UPF stand for user plane function, and we have a lot of functions assigned to UPF. So what UPF has to do by the 3GPP spec. But the idea is that UPF role is to connect the access network to the data network. That is the main goal for the UPF. Then now in the 5G, is I think the later part of 4G that you can place gateways, data plane gateways in edge places. That means that because of the 𝗃𝗃𝐶 design, there's a new protocol, new technique based on the SDN. It's called control plane and user plane separation. So that you can place your data plane entity like a UPF in your edge place, so that you can terminate some of your traffic at the edge instead of going to the goal. So this is, we call it as a ULCL, it's an uplink classifier. So you can see the third point that I am mark it as a packet routing and forwarding. So this is features that we are adding onto this UPF. Then what we have to do is UPF as important in the telecom vendors. We need to monitor that usage. So we want to know what how much traffic you send, how long you send, those is kind of monitoring. So we started supporting this UPF. Okay, so this is a functions and what is I develop. So we will go a bit on UPF. So as I said to you before, it's like a kind of router, kind of switch, but there are some difference because the packet processing model in the UPF is as explained in this 3GPP diagram. So this is a 3GPP diagram. They said that every session have different PDRs. PDRs mean packet detection rule. Is a kind of matching things. Then if it's matched, then you will check what you have to do for the FR. FR means forwarding action rules. What you have to do forwarding. You have to either forward the traffic, either block the traffic, either buffer the traffic. So this is the rules that you can do. So buffering and FR is working together. then you can do this flow, how you can treat your quality of service. So quality of service is the important aspect again in the 5G. So the enforcement you will be defining through this rule. So you will apply in this quality of service treatment. Then the final is a usage reporting rules, is the one that specify that, okay, what kind of usage information you have to push it to the SMF. So these rules to be hit by your flow. So it means that the flow is coming in the left side, then it's going through this rule matching. So it's a kind of flow tables. Generally, if you say the L2, L3 things like a switch router, then packet will go out. This is a basic packet processing model. So now we will see that how we can deploy it in developed in software as a hardware. So what is famous techniques that so far industry adapted? One is you can use 𝗀𝗹Me switch. So it's a well-known L2, L3 switches, virtual switches. So we are using today in the many cloud infrastructure. So this OVS can be extended to support this UPF function. Okay, so this is 𝗘𝗃𝗽𝗃 hardware, and it's can be optimized with DPDK is another framework to optimize. So one technique. Another technique is called vector packet processing. Is actually the vector packet processing is a kind of a technique developed by the Google. Now it's make it as sorry, not Google, it's a Cisco. Now it's make it as open source to the community to exploit. So its idea is to best using the resources in 𝗘𝗃𝗽𝗃 hardware. So this is a vector packet processing is a technique to exploit your resources in the 𝗘𝗃𝗽𝗃 hardware. So VPP is well known and well used in Cisco product. Now it's open source. So I am exploring based on this VPP technology. Another techniques is possible is a programmable switch. So you know, it's now the industry, telecom industry, moving through a lot of things. So we have SDN before talking about, I think 10 years back. Now we are talking about the P4. It's a programmable switch ASCII. So barefoot Tofino ASCII is a very well known. So based on this ASCII, some people program it in order to function as a UPF. So for example, Calum, there's one vendor from Canada, they are building a system. But again, the ONF, Open Network Foundation, they are building again this open source model to build this ASCII, not ASCII, the UPF module based on ASCII. So there are two initiatives happening. So I will participate one of these, and another possibility is Symantec and VPP. So there are another vendor working on these techniques. So there are many different ways to implement UPF. So today in my demo, in my work, I am using the VPP to do this UPF. What I do, what is the way that I can measure this matrix? There are plenty of ways that you can see that your UPF is best than others. So number of sessions you support, number of throughput is a packet per second. So say they are going with the terabit per second throughput. Then number of ACL, so access control list, sometimes we need to deploy in the UPN. So how much ACL you support, based on that you can say that is the best than others. So there are so many metrics, but I just put some of them is very crucial when we are developing the UP. So what I have done is basically, so SMF and UPF. So some of the source code I get it from SMF from the free 5G. So there's another initiative happening in the from Taiwan. So they are building all the component like AMF, UDF, PCF, SMF, everything is in Go. So my program already I started with NP Go also in Go. So I am good match with integrate. So I already started integrating with them. Second one I am using the UPF is basically the started work from the travel ping. It's open source again. You can see it in the travel GitHub. So it's based on this VPP. It's a C code. So I am extending to integrate completely with SMF and UPF. So this is the work that I am continuing. So all the patches, all the modification, I put it in the GitHub. So the blue box you will see for the testing. So once I do the SMF and UPF, so I can do the local test like SMF UPF perspective. Sometimes I can do with the simple user connect to the SMF and he send the data through the UPF to DN. So that's what I do, like a complete end-to-end integration here. So this is when I do this kind of test. So what I do typically is I just follow the 3GPP document. So 3GPP document says very clearly that what are the procedures that the network has to support. So well known is the registration. You know that how do you register to your network and how you can get access to the network. So this is a registration process. Then if you're ideal, then you want to make a session again, then you have to make a service request. So this is another 3GPP defined procedures. Then again, the handovers. So you as a mobile user, you always moving from different base station. So 𝗏𝗏𝐵s or 𝗏𝗏𝐵s. So if you move from one place to another place, so there's a handovers happening. So these handovers, there's a call flow we have to support. Right now, I started to support this registration, and that means that you can register to the network. Then after that, I set up the flow tables in the UPF, and you send the data, and you get back the traffic back to your user device. Then because of the edge computing, I am working on another project with some colleagues in US. They wanted to do this edge computing demo in Acronia project. So we want to support this uplink classifier. So I implemented on this existing UPF, and I have implemented, and I try to show the demo for them. Then I am continue on this work on the service request, handovers, and network buffering, and all the procedures. So it's going one by one. This is all my core part of my talk. So what I can say to you today is that we have some high-level features with the important features with SMFM and UPF. It's already there. Challenges always lot in the telecom product. So some of them is that when I when I working on the UPF, I don't care. UPF is going to work on EMB or massive IoT or ultra low reliability. Because when I use it for ultra reliability and low latency, I need to make it so latency less. So it means that I have to move from the software to hardware. Then only I can go from millisecond delay to microsecond delay. So these are the challenges still there, but we have a framework. SMF and UPF is not really microservice. So you know that when we are building a 5G core, so we coming from the nodes to functions. So the functions today is mostly perceived as a microservice. So we have to develop again to split into small services, these functions. So this is not yet done, so it's in the plan. So still, I am exploring different new features to add in it. Sometimes it's for the performance, sometimes it's a functional purpose. So this is just a module that anyone can use it if you want. So if anyone has an interest to explore and deploy the network, or you want to contribute through the innovation, you are welcome. And all the source code available in my 𝗦𝘂𝗽𝗽𝐻.SODI file. So you can search it, or you can contact me by email. So I am here to help you all. This is the end of my talk. I hope I have give you some idea about my development on the 5G core. So that's all.
Thank you, Dr. Siva. Thank you.
Thank you.
Yeah.
It's fine.
Okay. All right. So the next session is network slicing. Allow me to just say a few words about network slicing. Network slicing is a key 5G technology aimed at building customized 5G industry virtual private networks over the same physical network to accommodate applications with widely diverse requirements. Network slicing allows operators to offer different classes of services for different enterprise verticals across a common infrastructure. So without due delay, let me introduce Paulo Rufino Henrique from Sao Paulo, Brazil, to discuss on 5G Release 17, network slicing for OTT and IPTV services.
Thanks for the invitation, and it's a pleasure being here. Let me share my screen with you. Please let me know if you can see it.
Yes.
Can you see it?
Just
Yep.
like
Okay.
Yep.
Thank you, Kanesh, for the invitation, and it's a pleasure being here with this group. What I'm going to talk today is about network slicing and the importance of network slicing for OTT services and IPTV services. The reason why I bring this topic, it's because it's been my topic during the last 5 years. I'm an electronic engineer working with IPTV and OTT services. and I spent the last 8 years in England deploying UHD TV channels and managing OTT from the telcos providers to our end users. And the last 2 years, I'm the integration engineer at 𝗬𝘂𝗽, in which we provide personalized recommendation platform systems for OTT services and IPTV using semantic algorithms, which enable us to provide contextualized and cognitive personalized recommendation, in which I will bounce in the end of this presentation, delivering to all of you a demo. Right. So the main idea of this presentation is to emphasize how is important for us and to have 5G implemented across all the verticals, and especially on OTT and IPTV services, and show to you the benefits that 5G release 17 can bring to the industry, and especially in the media broadcasting industry. As we saw, we are living in this pandemic situation. We can understand that the behavior of our end users, subscribers across the globe has changed, has shifted dramatically, especially because everybody now is indoors or carrying out their activities and based on home office. What we have seen recently are some very important aspects heavily across services, but mainly on the media and broadcast industries, entertainment industries. Why? As we can see here, some highlights of the lockdown effect. These are some headlines that I